Welcome to the session. I'm Rachel Blackburn. I'm on the corporate operations team at Oracle, and I'll be moderating the webinar today. This webinar is part of the Oracle at Oracle webinar series, where we have the opportunity to hear from the executive team that reimagined Oracle. In this series of webinars, we share insights from our own journey to the cloud and demonstrate how we're using Oracle Cloud, and today specifically Oracle Cloud Infrastructure, to power our business and enable exceptional and customer and employee experiences. And we'll share our learnings along the way so that others can do the same. And let's dive into today's topic. Over the course of the webinar today, you'll hear how Oracle is running some of our mission critical business systems on autonomous transaction processing database. Now I'll pass it over to your host for today's webinar, Kishan Agrawal, to introduce himself and tell you about what he does at Oracle.
Thank you, Rachel. Hello, everyone. Welcome. I'm Kishan Agrawal, Vice President of Technology and Infrastructure in a group called Oracle Application Labs here at Oracle. I'm currently leading the effort to migrate all of our corporate application infrastructure and systems to cloud, Oracle Cloud, as part of our overall cloud transformation journey. I'm going to talk about specifically how internally at Oracle, we run critical business systems on autonomous database in our Oracle Cloud infrastructure. I'll cover high-level strategy, our migration approach, some of the benefits achieved, and a few lessons learned. And at the end, we'll have time for Q&A. Let's begin with a brief intro about our group. Oracle Application Lab is the group responsible for implementing and managing all the business applications that run Oracle, whether it's ERP, HR, finance, all of those. So in that sense, we are like one of the largest customers of Oracle, and we go through the same experience, the same set of challenges that many of our customers would go through. We are part of the larger product engineering organization, and we have a direct feedback loop with our product teams. Our vision is to be a 100% cloud-only IT organization and run all of our enterprise applications and workload on Oracle Cloud applications, the SaaS services, as well as Oracle Cloud Infrastructure, the IaaS services. Now, for migrating all of our enterprise systems to cloud, instead of doing it in a big bang migration approach, we have adopted a coexistence model, coexistence between our on-prem and cloud as a step towards cloud. And we have been moving all the system in phases, and it has been very successful. And from an infrastructure side of things, there were two key ingredients for this success. First, we had already consolidated all of our on-prem databases, hundreds of databases, production, test, DR, on a few set of Exadata servers, which not only made it easy to operate, reduce cost, but more importantly, now it is making it easy to migrate these databases to cloud. And the second key ingredient is the ability to use the same set of tools like Oracle Enterprise Manager and other management services in Oracle Cloud to manage both on-prem and cloud system. These two factors have made it very easy for us to coexist and then migrate everything to cloud. Now, before I jump into the details of autonomous database, let's first talk about the cloud transformation journey that we are currently going through. Now, in a service-oriented world that we are in now, the expectations from our employees, our customers, are very high and also changing rapidly. So we in IT also must continuously innovate and stay ahead of those expectations. So as Oracle, as a company, transformed itself from a product company to a service company, we also needed an infrastructure platform that would enable us, the IT group, to innovate faster and meet the changing needs of our business. Here I'm showing a comparison of our systems when we were on-prem versus in cloud infrastructure. Earlier on our on-premise system, we were constrained by these challenges that you see on the left-hand side of the screen. First, slow pace of innovations. We will get new infrastructure or platform services in quarterly releases, or in many cases in yearly release cycles. And when it comes to hardware upgrades, it will be even longer. It will be like 5 years, 6 years cycles. So if you think about it, even if there is latest version of Exadata offering available, it would have taken us years before we move from the old Exadata to the new Exadata service. We're constrained by fixed capacity because we will have this yearly capital expenditure budget, and any changes would require a lot of planning. There were limited scalability options, and in most cases, when we were doing any scale out or scale up, it would require downtime and a lot of manual work and configuration changes. Most of the system provisioning were manual, and we used to have frequent and longer outages for maintenance, upgrades, and those activities. But since we moved to Oracle Cloud Infrastructure along with all the autonomous services, it has given us the faster pace of innovations. There are frequent releases of new features and capabilities, and we are always on the latest version of infrastructure, the hardware, as well as other platform services. There is flexibility to do need-based budgeting. So for example, when we need more compute or more capacity, we just subscribe for more. There is complete elasticity to scale up or scale out. Say during heavy workload during quarter end, we could easily scale up the required systems. Then there are automated system provisioning. Of course, the autonomous services does the provisioning for itself, but for other services also, there are APIs and command line interface to build the fully automated provisioning system. And finally, we are able to achieve much better uptime between 4 nines and 5 nines. 4 nines is like 99.995% uptime, which is like few minutes of downtime in the entire year. So the cloud infrastructure provided us the next generation platform to run all of our enterprise workload. Now, Oracle Cloud Infrastructure provided some unique capabilities that help us transform the IT group from being very operational day-to-day focus to more innovation focus. Let me talk about some key capabilities. First, of course, is the autonomous services, the autonomous database, autonomous Linux, and with all of its self-driving capabilities, such as self-patching, tuning, upgrading, it eliminates a lot of day-to-day operational work for our IT group so that they can focus on other innovative initiatives. Database is always up to date in terms of security fixes and other critical patches. And there are no downtime for patching or other activities in these autonomous services. Second key feature is the security. Security is always on. What I mean by that is when we provision an infrastructure or platform services in OCI, all the security options are turned on by default. So it is always secure by default. There are things like there are isolations at all layers of the services. And there are encryption end-to-end, whether your data is inside Oracle database or other storage services, or in transit between systems, it is always encrypted. All the security hardening configurations or best practices, recommendations are by default enabled or already done when you instantiate your services. So we didn't have to like go through an extensive security reviews or configurations or needed like a super specialist to secure our workload. Next, OCI provides a complete set of monitoring and control capabilities. Services come with built-in telemetry that provides 360-degree view, runtime view of your systems. And many services, including autonomous database, comes with auto-healing capabilities so that we don't have to do anything when something goes wrong. It repairs and restores services itself. And then there are a full range of APIs and interface to manage and control your services. Of course, you can do all those through the UI console, but there are command line options to do that as well. And finally, OCI provides all the APIs and SDK to build full stack continuous delivery pipeline. When we were on-prem, we were able to do continuous integration and delivery mainly for the application layer. And all the infrastructure layer component were built manually. And we used to do only CI/CD for the application stack. But with Oracle Cloud Infrastructure, we are truly able to achieve the infrastructure as a code paradigm, where all the infrastructure configurations, setups are managed as code, and we are able to deploy, configure, provision the infrastructure services in our automated pipeline along with our application stack. Next, I want to talk about, focus a little bit more on the Exadata platform itself, because there are various options to use Exadata services. So I will compare different features and capabilities. So as you probably know, Oracle Exadata Server provides the best platform to run Oracle database workload. Oracle Exadata platform has delivered many innovations over the last 10 years or so, such as smart scan, hybrid columnar compression, in-memory processing, and many other industry-first innovations. But I'm not going to focus on those capabilities. I'll focus mostly on what you get on top of if you move to our cloud services. Because when you run on Exadata on-prem or anywhere, you get all those benefits and you get the best platform to run Oracle database workload. But when you move to Exadata Cloud Service, you get all those benefits, but you get much more. Because Exadata Cloud Service is like a plug and play service. It comes pre-configured, everything is ready, and you can provision the service as well as database in minutes, whether using the UI console or using the command line. It includes a variety of cloud compatible tools to patch, upgrade, and to build other automations in the cloud. The storage management, the self-storage management, which if you're on-prem, you do that yourself, but with Exadata Cloud Service, it is automatically taken care by the cloud service itself. And then there is native access to Oracle Cloud Object Storage, which not only provides very cheap and scalable storage options, but these objects, anything you store in Cloud Object Store is natively or easily accessible from the database. So you can use it to store data or use it to transfer data in and out of system or to build other operations. For example, the automatic backups that comes with Exadata Cloud Service, it does the backup automatically on the Oracle Cloud Object Store. And more automation features are being released by Exadata Cloud Service frequently. And these features, you can start using those features as soon as they are available instead of waiting for like you used to do on-prem. And you are always on the latest version of Exadata, unlike on-prem, where you have to wait for years before you move to newer versions or newer capabilities. Now, if we take one step further, as you move to autonomous database service, you get all the core platform benefits of Exadata and all the innovations of Exadata and Exa Cloud Service, but you get much, much more. First and foremost is the autonomous capabilities. The self-driving capabilities like patching, scaling, tuning, securing, everything is done automatically by the service. It always stays up to date in terms of security fixes and other critical patches. And like XRCS, you can provision these services in minutes, whether you want any shape, whether it's full rack, quarter rack, any shape you want, whether you are provisioning it, because it comes in two flavors. You can have shared mode or you can have dedicated mode. In dedicated mode, you get the full rack or full server for yourself. But in either case, you can provision these services very quickly. You don't have to like work with Oracle ACS or other services to stand up these services. Then many operational tasks can be done in few clicks. Say you want to clone a database, or you want to move a pluggable database from one container database to another container database, you can do that in clicks. Even setting up your entire disaster recovery site on another OCI region can be done in just few clicks or a few commands in the command line interface. The next big capability is the dynamic scaling of CPU. So you can increase or decrease CPU allocations for a particular instance of autonomous database without any downtime or configuration changes. You can do all through the console or the command line without any disruptions or outages or even changes to your live production systems. By default, these services are provisioned as highly available and always secured, as I mentioned earlier. So as one of our DBA described it, it is pretty much like load your data and forget about administration service. So all you have to care about is your design of the schema and how you bring data to the services. You don't have to worry about any administration service. So we talked about three options for running Oracle database on Exadata: the Exadata on-prem, Exadata cloud service, or using autonomous database. All three have the same advantages of the underlying Exadata platform. And whether you run it on-prem or you run it in cloud, you can have seamless coexistence between on-prem and cloud because you'll be able to use the same set of tools like Enterprise Manager to manage your system across cloud and on-prem. And when you're ready to migrate, it is very easy to migrate from your on-prem Exadata service or Exadata system to Exadata cloud service or to autonomous database. We'll talk about more detail about that migration options in next section. But before we go there, these three last two offering here are also available in two options. With the recently announced Oracle Cloud at Customer, you can have Exadata Cloud Service as well as autonomous database in your own data center. You can run it in Oracle Cloud Infrastructure as well as inside your data center. For our internal use, we are running all of our enterprise workload in through public cloud, Oracle Cloud Infrastructure. Currently, we are not using the Cloud at Customer offering. With that, now I'm going to discuss our strategy, the approach that we have taken to migrate our on-prem system to cloud, and particularly to autonomous database. So we came up with a framework for migrating our systems to Oracle Cloud Infrastructure. This framework takes both business as well as technical or IT aspect into consideration and has been successfully adopted by us as well as other groups in Oracle. For example, our Industry Apps Business Unit has also used this framework to migrate all of our industry cloud services to OCI. As you see in the slide, there are 4 stages in this framework: envision, architect, engineer, and launch. And you can migrate, if you decide, if you choose to, you can migrate all of your workload in one cycle using this framework, which will be like a big bang migration, or you can use it as in an iterative manner to migrate in phases. Now let's look at each of these stages. The first stage is envision. This is when you establish the vision for your cloud transformation and align on that strategy with your key stakeholder. Of course, you'll also need the support from your executive management to embark on this journey because it would impact your other corporate priorities. For us, the vision was to be 100% cloud only IT organization and to transform all of our business processes and provide a delightful experience to our users using both Oracle Cloud applications and cloud infrastructure. So with our executive management support, we align this strategy with all of our business partners, and we align our corporate priorities and work streams with these initiatives. The next step is architect. So once the vision and strategy alignment is done, you start architecting the migration. There are 2 key activities here. First is the technical work to come up with a technical architecture or the blueprint on how you would migrate and how you would run in cloud. So for that, you do simple proof of concepts. You move simple applications to understand various cloud technologies, how different building blocks like security, networking, everything works in cloud, how autonomous database works. So you run this simple application to understand the technology as well as to learn how to operate in cloud. And also you also test or migrate some small system to understand the migration options itself. So essentially you build the blueprint and the foundation for the actual migration. The second and equally important activity is to prepare your org for that change. You identify and acquire the required skills. Some of your technical, say, resources might have to upgrade their skill to operate in cloud. You also define the new, probably you'll have to have a new change management process or a new support process. So in this phase, you define and start working on those change management aspect of this migration. Once you're done with the architect stage, you move to the engineer stage. This is when you do the actual development of the migration and also you test the migration. So you use various migration tools and utilities provided by Oracle to prepare the migration options. And you migrate a few of your test systems using those options, and you make adjustment, you make refinement to come up with your final approach for the production migration, which will have minimal downtime and minimal disruption. And this is when you move to the launch stage. Once everything is tested and ready, you perform the final cutover. You move your production systems, you go live with that, and then immediately you move on to the post go live activities like any stabilization, streamlining that needs to happen. And once your production is stable, then you start leveraging or start exploring new capabilities in cloud to continuously improve your systems, to build new solutions, or to adopt new technologies. And this is what we call like move and improve. First, you focus on move, and then once you're stable and operating in cloud, you start improving or exploring new capabilities in the cloud. Now, this would complete one full cycle of the migration framework. And as I mentioned, if you have adopted a phase migration, then you can iterate through these stages to move the remaining system. Obviously, you don't have to go through all the stages again. Most likely, your envision and architect stages are remain same. So you only iterate between your engineer and launch. Based on your type of systems or source and target system, you might have to design a new migration approach in the engineering phase, and then you launch. Now I would share how we did the actual migration to migrate our enterprise workload to cloud. We adopted a four-step migration approach, which help us minimize downtime as well as to reduce any disruption to business. The first step is prepare. This is when we prepare the source system or on-prem system to migrate. We archive any old data that we cannot purge, but we need it for, say, legal hold or other reason. We archive this old data to Oracle Cloud Object Store. And if any data which is no longer needed, as for our corporate data retention policy, we will purge those data. We'll also retire any old artifacts or application component or other system that we no longer needed. So essentially, we go through a cleanup exercise rather than blindly moving everything. But this is an optional step. If you decide, if you choose to, you can move your system as is. But one of the other key consideration here is, let's say you are still deciding or you still have time before you move to cloud, you should consolidate all of your on-prem databases, if possible, on Exadata racks, on Exadata platform. That's what we did. We consolidated hundreds of on-prem databases on a few set of Exadata racks. And this has now made it very easy for us to migrate to cloud. Or you can, as part of the migration, you can decide to consolidate in the cloud. So in your on-prem, you might be running the database in different servers, different hardware, different operating system. You should decide, or you should plan to consolidate all of those in Exadata Cloud Service or autonomous database. Once you're done with the prepare stage, you move to the build stage. This is when you build the new system in parallel in cloud using the required cloud services. You migrate bulk of the data in advance, and you verify whether the data is intact, all the integrity are there. And to do the actual migration, there are a lot of different tools that you can use based on your use cases. For example, if you're moving to Exadata Cloud Service, there is an offering from Oracle called Zero Downtime Migration. It automates the end-to-end migration for your database without any downtime. But based on your other like source system configuration, you may decide to pick like transportable table space or simple export import, or you might build a DR system in the cloud and do the actual cutover during the transition. Or you can use Golden Gate service to replicate bulk of the data in advance. For example, that is one of the approach we took when we migrated system from on-prem to cloud. We wanted to migrate only one of the schema, not the entire database. So we use Golden Gate to replicate all the data in advance and verified that. This is when you also migrate or deploy your application or the mid-tier artifacts to the target or to the new system in cloud. Now, during the actual production cutover, you do the delta sync. And based on your data migration strategy that you have chosen, you might have no data to be synced or very minimal data to be synced. Again, the goal here would be to minimize that delta sync and do all the sync as much as possible in advance. In this step, we also synced other artifacts, like we have attachments, files, and other like mid-tier artifacts. So we moved bulk of them in advance, and during the actual cutover, we only did a delta sync. Now, next step, once all the delta sync is done, you put the on-prem system in read-only mode and switch to the new system. You redirect all the endpoints and URLs and all the traffic to the new system. And once everything is verified and working on the new system or in the cloud, you shut down your on-prem system and keep it down for as long as you need. And eventually you decommission or archive that old system based on whatever is your data retention or corporate data retention policies. And we use this is like high level approach that we took to migrate most of our databases to cloud. Now, I just wanted to compare the three platforms in terms of administration capabilities. You have your Exadata on-prem, Exadata cloud, and autonomous database. In Exadata on-prem, we used to do all the administration activities like patching, upgrade, configurations, everything. When we move to Exadata cloud service, it is like semi-automatic. Some tasks are fully automated. For example, the self-server management is automatically done by the services. The rest of the tasks like patching, upgrade, we are responsible to do those tasks, but the service provides tools and APIs to easily perform this task or build automation for this task. And when you move to autonomous database, everything is automated, except one task, which you see in the last row of this table, the schema design. And schema design is the task that you do it regardless of your platform of choice, because you need to design your schema based on your application requirements, data models, and your application design. So you still have to do that in autonomous database. You design the schema, you load your data, but after that, everything else is taken care by the autonomous database. Now, in addition to running critical transactional system on autonomous database, we also run our global corporate data warehouse using OCI and autonomous data warehouse service. I'm not going to cover the detail here, but just wanted to share a few high-level key points. The slide essentially shows the high-level architecture. The corporate warehouse is built on OCI and uses many of our OCI services, including autonomous database. And this is our global central corporate warehouse that is used for both operational and analytical reporting by all of our business teams. On the right-hand side, you see the data feed from our systems, which are still on-premises, and we feed data using Oracle Data Integrator or Golden Gate. Similarly, data from our cloud, SaaS, or other system, we feed those data using ODI, Golden Gate, and the new Oracle Data Flow Services is OCI. In terms of the center part, the actual data is divided into three logical layers. The first one is the raw data layer, or many of you might call it the data lake. The data lake is built using a combination of Oracle database, object store, and our big data services. This is where we ingest and store all of our raw or untransformed data. And then on top of this, we build the next two layers, the foundation layer and the access or performance layer. Both of these layers are built in the database. Foundation layer is where you have the curated data layers containing all of your confirmed dimensions, facts, and all. And the access or performance layer is the data optimized for your reports and dashboards and those uses. And we use Oracle Data Integrator and Data Flow to build this curated data sets from the raw data layers. And then on the top of this architecture, you see that we use Oracle Analytics Cloud and Oracle Data Science Services to build reports and dashboards and other data science solutions. Main thing I wanted to call out here is this is our global central corporate data warehouse that runs all of Oracle data warehouse and analytics solutions. And just wanted to share one data points. When we moved some of the reports from our legacy on-prem system to this new platform, we almost saw 10x performance improvements. So we talked about our migration strategy, the approach, and the expected benefit, what we were anticipating by moving to cloud. So next, I want to talk about some of the key benefits that we actually achieve by running our critical enterprise workload in autonomous database as well as in OCI in general. First, moving to autonomous database has been a complete game changer for us. It provides a fully autonomous service that deploys and manages the database for us. It is completely self-driven, as I mentioned, does patching, provisioning, scale up, and all those activities. So with all of its self-driving capabilities, we are now running mission critical applications on autonomous database with zero system administration. For example, when we move one of our customer lifecycle management system, when we were running on-prem, we used to have multiple dedicated DBAs or database administrator to manage and operate the database to perform day-to-day operations, tuning, patching activities. But once we move that system to autonomous, all those tasks are automatically taken care by the autonomous service. Yes, you still need the admins to manage your application tiers or mid tiers, but for database, no resources required to manage those databases. Next, autonomous database has enabled us to deliver better and faster solutions to our business at lower cost. Let me share a few numbers. Again, by moving that one of our customer lifecycle management system, we have achieved at least 2x performance improvement with 40% cost savings. The cost saving includes both the cost of the cloud services in comparison to the cost of managing your on-prem hardware and software, as well as the cost saving that came from the resources required to manage this system, on-prem versus cloud. Next, we are able to deploy new systems and applications in minutes instead of months. For example, earlier, when say business wants to deploy new applications, our functional team, they request a new system, then we'll go through all the procurement process, the server build, deploying software, configuration. So it would take months even before we can have a test system ready. Now, it just takes a few minutes even to provision a dedicated Exadata racks. And with all the automations and autonomous capabilities, we have been able to redeploy 35% of resources from regular operation work to work on new projects. And with Oracle Cloud Infrastructure, with its autonomous services, it unlocks new possibilities for our business. First, we are able to provide exceptional or new experiences for our user using better and newer capabilities in cloud. For example, using the AI and ML capabilities in the database as well as in other OCI services, we're able to gain new insight from our existing data set as well as build new experience for our user. With better uptime and better performance, we are able to provide better experience as well as improving the user productivity for our users. And as I said earlier, for some of our mission critical system, we are able to achieve almost 99.995% uptime, which is like a few minutes outage in an entire month. And with our corporate system running in cloud, our users are able to access all of our corporate applications anywhere, anytime on any device, which is very crucial or important with the current COVID situation. And finally, with a faster turnaround on our infrastructure build, our business is able to deliver new solutions to market at a much faster pace. With that, now I'll share a few key learnings that we have learned in our journey to cloud as well as to autonomous database. The first, adopt a coexistence model. We adopted coexistence model instead of doing a big bang migration as a step towards cloud, and it has been very successful. This helps us build the foundations, all the required building blocks, learn how to operate in cloud, and then start migrating all the critical and key system in phases. And as I mentioned earlier, the ability to use the same set of tools and utilities help us operate in coexistence model. Second, consolidate all of your source databases if you have not already done on Exadata servers, either on-prem or as you're part of your migration to cloud. It not only makes it easier to operate and reduce cost, but it also makes it easier to migrate to cloud. Third, minimize downtime using all the tools and utilities provided by Oracle. So based on your source system and target configurations, there are already many automated tools and options to minimize or completely eliminate downtime. So before you, as you start building the solutions and all, explore those tools, because it's not that when you move to cloud, there'll be like a large or like an extended outage or anything. You can almost switch to the new system without any disruptions. And finally, upgrade skills. With all the day-to-day database operational work or other operational work becoming obsolete, invest in upgrading skills. For example, say DBAs who used to spend time on patching, maintenance, and other such activities can now help with your other initiatives like building a data pipeline or optimizing your schema or coming up with new architecture or new cloud native architecture. So invest in upgrading those skills of your existing resources as you prepare to move to cloud. That essentially conclude my presentations on our strategy, our migration approach, some of the benefits and lessons learned in our journey to cloud. With that, I'll hand over to Rachel for Q&A.
Perfect. Great timing, Kishan. And just a reminder to everyone on the line, if you have questions, you can enter them through the Q&A function that you'll see probably at the bottom of your screen. So I'll start with a question for you, Kishan. How does the autonomous database help with new applications development, especially as it relates to data-driven applications?
Sure, great question, Rachel, because I have so far talked about primarily how we moved all of our existing application or systems, right? But we also started building a lot of new applications in cloud, directly in cloud, as in cloud native application. And autonomous database helps in two aspects. First, even to build traditional applications, it has a lot of like low code application development capabilities like Apex, or OCI provides Visual Builder Cloud Service, which helps you build very sophisticated application very easily. And for your data storage, autonomous database eliminates all those like optimization, provisioning, all those activities that you typically do when you're building a new application. You do all those things as part of your development process. You need to think about how to, provision, how to design, schema, and all. So many of those tasks are done by autonomous database. So you just provision a simple database, you connect your development tool, and you start developing. Now, to focus on data-driven apps, which is the new trend where you have variety of data sets, structured and unstructured. You may have spatial data, or you may have documents and all those. So traditionally or earlier, people used to build this application, all this data-driven application by connecting all these data sets residing in different types of database and all. With Oracle Autonomous Database, and especially with the converged database paradigm, you can have all these different types of data, whether it's JSON data, unstructured data, geospatial data. You can have all those data in the same database, and you can use the same set of programming languages or tools to leverage, connect, integrate all this data to build your application. And then finally, to use machine learning and AI capabilities, Oracle Autonomous Database comes preloaded with a lot of algorithms and machine learning component. So the idea is, instead of moving data outside of database and building machine learning, bring algorithm inside the database. And of course, if you want to use other tools, there are a lot of connectors to connect to your whatever be your favorite or your choice of machine learning tools. You can connect to database to build those data-driven applications.
Great. Second question, what was the previous environment you moved from, you mentioned, that resulted in 40% cost savings?
So that particular example that I mentioned, we used to run that system already on Exadata on-prem, right? So, but it was a like few generation older. So as I said, we were not able to upgrade or migrate to the latest generation of Exadata, neither were able to go to the latest generation of the software. So we were running on Exadata and other on-prem hardware, but when we moved to cloud, we directly moved to the latest version of Exadata as well as the software stack. So not only it performed better, but even if we compare the cost of service, the cost of hardware running on-prem versus the subscription, the cloud subscription in Oracle Cloud, and then we compare the resources, right? How many DBs we need to manage the on-prem system versus cloud. That's when we gain 40% cost saving, and that is for one system, right? And if we compare across the board, the overall cost saving for Oracle IT by moving to Oracle Cloud is in millions.
Wow, awesome. And getting some questions from the audience here. Could you expand on the self-patching characteristic associated with autonomous database? For example, if an EBS application needs to be patched or upgraded, will the autonomous database take care of the associated database patches?
So great question. So there are already, before you answer that question, there are a lot of recommended architecture and recommended, certifications and configurations already published if you are planning to move your EBS system to Oracle Cloud or Autonomous Database. So Autonomous Database automatically takes care of all the critical patches and security patches and all those. For any major upgrades, you have option, you have option, it will do it automatically, but you can pick the window and timing, so that if you want to say align your EBS migration or EBS upgrade with the latest version of database, you can align those windows by picking the time when you want to upgrade. So yes, it will do the patching automatically, but you have the option when you want that to happen.
Great. And did you tune the database at all for specific applications during migration, or did everything kind of work as it was set up, I guess?
Yeah, great question. And that was kind of one of our, pleasant surprise for us. When we moved system to autonomous database, we actually did not do any kind of like changes in the application code. We moved as is, like whatever the SQL queries and all those were running on-prem, we moved. So we did some changes in the application code more in terms of connectivity and the cloud native configurations and those kind of things. But when it comes to the actual queries, we did not make any changes in the queries to optimize. The performance benefit came, one was from the all the the infrastructure, that the next gen 2 infrastructure, which has better IO, better performance. It runs on the latest and greatest hardware, as well as the latest version of the Exadata platform itself. And then on top of that, the autonomous database does the tuning of any kind of bad queries automatically. So no, we did not like made any code changes or manual tuning of those queries.
Great. An interesting question. This might have to do a lot with timing. What is your driver to go in the direction of Oracle Cloud Infrastructure versus Cloud at Customer solutions?
So we started our cloud journey a few years back. It's almost like 3-4 years back, because we as I said, we use all of our Oracle software or applications to run our entire business, whether it's a HR, finance, supply chain, as well as data warehouse, analytics, everything. So we have it. We are, as I said at the beginning, we are like one of the largest customer of Oracle, and we have been moving this system in phases. So when we started our journey, the cloud at customer option was not offered or not available at that time. So it was just recently announced. But by now we have already moved a lot of our systems and application to cloud. And we are, happily operating in the cloud infrastructure in the public cloud. We have not yet considered whether we can now switch back to cloud at customer. My guess is we will continue to operate in the true public cloud, Oracle Cloud infrastructure, because it has been working great for us so far. But the answer is, when we started our journey, this option was not available to us.
Great. And are you able to share some insight into which major applications we migrated first, like HCM, ERP? What was the logic behind the timeline, or was there one?
Sure. So our application migration strategy, as I said, was in phases. So the first was to build the foundation. I'm now moving a little bit towards the application migration. So first step was to build the foundation. This is where we were still operating almost all of our enterprise applications in Oracle E-Business Suite, the EBS on-prem. So we first moved to a new global chart of accounts using Oracle Fusion. That set the foundation for the subsequent migration. And then we started moving some of the application, like say Oracle HCM talent management, or moving to Oracle configure pricing and quote system, or to Talio recruitment. So we started moving some of this surrounding applications, as well as started moving in terms of the core application. We started with the foundation, and then we started moving subsequent phases. So we first moved the talent management, then we moved the core HR, then we started moving some of the finance modules like expenses, procurement, and all. And now we are in the middle of migrating the rest of our ERP system, like order management and AR and all. We have already moved our sales cloud completely, as well as our supply chain. So we did all this migration in those phases.
Great. And could you also expand on the difference between Oracle Exadata Cloud Service and Autonomous Database?
Yeah, I think I covered a little bit on the presentation. So in terms of the core database platform, right? The the cell storage or all the core database engine, there are similarities, because the platform for both Exadata Cloud Service as well as Autonomous Database is that core Exadata platform. But in Autonomous Database, a lot of those operational work are done automatically by database. Say if you're running on Exadata Cloud Service, if your query performs badly, then you need to figure out how to optimize the query, whether you need a new index, all those optimization you need to do. Or let's say a latest patch is available, then you need to deploy that patch yourself. Yes, you can use the utilities provided by the cloud service to deploy or upgrade, but you do that yourself. In autonomous database, it does all those things for you. So it is not, it not only does automate all the operational activities, it does other things as well, like this, as I mentioned, the tuning or optimization of your database, automatic recovery. If there are any failures or any issues your system, it self heals and self restores the services. It is always runs in redundant or multi node fashion, so there is never an outage or there is no data loss for anything. So I would say that autonomous services is like extra data service plus make all the automation on top of extra cloud service.
Great. And I think we have time for one more question before we wrap up. Final question. For our new Cloud at Customer offerings, can we confirm who is going to manage the databases that customers will have in their data centers?
Sure, I'll give a short answer, and then probably there are a lot of documentations are available. But short answer is, it is like you are running Oracle Cloud in your data center. So Oracle will ship all the hardware, it will establish connectivity, the minimum set of connectivity and all, and Oracle will operate your that infrastructure or that cloud. So you don't have to do any kind of operations or any activities. Oracle will do all the management operations and all those activities. So it is exactly like how you would use these services if you are operating or if you are using the services in Oracle Cloud. So think of it that the Oracle Cloud just got extended inside your data center, but the same set of service level agreement, the same thing that Oracle does for you in Oracle Cloud, it will do the same thing inside your data center.
Great, yes. And if you have further questions on Cloud at Customer, we'll provide an email and you can reach out to us and we'll get you connected with the right folks. Great. And so it is the top of the hour. That's all the questions that we have time for. We're going to put a poll up on the screen. And if you could please take a moment to let us know what you thought about today's webinar. We're always looking to improve or, continue to go in the right direction if that's where we're headed. So after this webinar, you will receive an email follow-up within the next 48 hours or so with the replay that can be shared with whomever. It'll be on Oracle Video Hub. And again, if you have any other questions about any of the topics covered today or how we're using any of our other solutions at Oracle, you can reach out to Oracle at oracle-contact_ww@oracle.com, and we'll connect you with the right Oracle experts to answer your questions. And if you are an Oracle Cloud customer, you can also continue the conversation on the Cloud Customer Connect community. So thank you all so much for your time today, and we hope to see you virtually, of course, on future Oracle at Oracle webinars.